A shrimp the size of your thumb generates a bubble that reaches 8,000 degrees Fahrenheit. That is hotter than the surface of the sun. And it does this with its claw, underwater, in about 1 millisecond. Let that land for a second. Not a laser. Not an explosion. A claw snap. From a crustacean you could accidentally step on at the beach. And here is the part that should genuinely disturb you. The bubble is not what kills things. The bubble collapsing is. You would be crushed by the implosion before you even registered the sound. This is cavitation, and it is one of the most violent physical processes in nature. It happens all around us, quietly, at scales we almost never talk about. So let us actually understand what is going on here, because the physics is genuinely stranger than the punchline. When a snapping shrimp, species name Alpheus, snaps its claw, it does not simply make a loud noise. The claw moves so fast, around 90 miles per hour, that it creates a pressure differential in the water around it. Water, under the right conditions, does not just move. It tears. When pressure drops below a critical threshold, the liquid water itself rips open. Not metaphorically. The molecular bonds between water clusters cannot maintain cohesion. A void forms. A bubble of near vacuum appears in the water, roughly the size of a sesame seed. Now here is where people's intuitions break down completely. Most people think the bubble popping is where the energy releases. That is wrong. The snap creates the bubble. The bubble is a low-pressure void surrounded by the full crushing weight of the surrounding ocean. The water rushes back in from every direction simultaneously. And when it does, it converges on a single point. Think of it this way. Imagine you are in a stadium. 60,000 people all sprint toward the center field at the same time. Every kilogram of water within reach is doing exactly that. To a single point. In microseconds, the converging water supercompresses the gas trapped inside. Temperature spikes to somewhere between 8,000 and 15,000 degrees Fahrenheit, depending on the measurement method. For a fraction of a microsecond, that tiny point in the ocean next to a shrimp's claw is plasma. Actual plasma. The same state of matter as the sun's corona. The collapse also emits a shockwave. Not a sound wave, a shockwave. There is a difference. Sound carries energy as pressure oscillation. A shockwave carries energy as a violent, supersonic front. The shockwave from a snapping shrimp's cavitation bubble travels outward and can stun or kill small prey instantly. The shrimp does not even need to touch them. If your hand were the size of a shrimp, and you snapped your fingers with this mechanism, the shockwave would stun a small fish at a distance of several centimeters. Proportionally scaled up to human size, you would have a biological hand grenade. If you are finding this as wild as I did the first time I dug into it, subscribe now. This channel is specifically for the science that textbooks stripped of all the insanity. We keep every gram of it. Now here is the second layer, and this is where it gets philosophically strange. Snapping shrimp are not rare edge cases. There are over 600 species of them. They are so numerous in tropical and subtropical oceans that they collectively produce one of the loudest continuous sounds in the ocean. Louder than shipping traffic. Louder than whale song in aggregate. The ocean floor in warm regions crackles constantly with millions of microplasma events happening every second. During World War II, the United States Navy was genuinely baffled by this noise. Submarines were trying to use hydrophones to detect enemy vessels. The ocean was generating an incomprehensible wall of crackling static. It took years to identify the source. An animal smaller than a human finger was defeating military sonar across entire ocean regions. And the physics gets stranger still. The shockwave from cavitation is not just used for hunting. The shrimp uses it for communication, territory defense, and coordinating with cleaning station partners. A biological shockwave cannon that doubles as a social signaling device. Now here is the implication that should sit with you. Engineers have been trying to harness cavitation for decades. And the problem is not generating it. The problem is that cavitation destroys everything it touches. Ship propellers suffer catastrophic surface erosion from the very bubbles they create. Pump impellers disintegrate. Industrial systems rated for decades of use fail in months when unexpected cavitation develops. Nature solved this in a claw. The snapping shrimp's claw withstands repeated cavitation events, thousands per day, and shows minimal wear over its lifetime. The material science of that claw joint is something engineers have not been able to replicate. The joint geometry channels the shockwave away from the biological tissue with a precision that current manufacturing cannot match at that scale. We are not just watching a weird little animal do a cool trick. We are watching a biological system that has solved an engineering problem we have not. Cavitation-based weapons, cavitation-assisted surgical tools, cavitation-driven water purification. All of these applications exist in prototype form. All of them are limited by the damage cavitation causes to the devices generating it. The shrimp does not have that problem. It just snaps again. The universe gave a thumbnail-sized crustacean a plasma-generating, shockwave-emitting, sonar-defeating tool, wrapped in a material that survives its own destruction repeatedly. And we are only just beginning to understand how. This is the actual frontier of science. Not the clean-answered stuff. The part where biology is still 20 years ahead of engineering and laughing at us. If that unsettled you in the best possible way, you are in exactly the right place. Hit subscribe, because next we are going into the mantis shrimp, which hits with the force of a bullet, also using cavitation, and also does not break its arm doing it. And that story is somehow even more unhinged than this one.